What up, math homies? Today we're going to be going over exponents in scientific notation. Um, we won't really be going over scientific notation. Basically, most intro science courses will take you through all that. So we're not going to spend the time here. We're mainly just going to talk about exponents. And so what are exponents really? Well, I'm sure you've seen them before. Basically, it's, having a number floating in the upper right-hand corner of another number. Visually, that's what it is. But what does it mean? Well, notice that when we have something like 4x, right, multiplication, 4 times x, multiplication is really just addition. So what does this really mean? It means 4 x's added together. So x plus x plus x plus x. Okay. So in that vein, what does 4 times 2 mean, right? It just means 4 2's added together. 2 plus 2 plus 2 plus 2. Now, because from last section we talked about the properties of the reals, we have the commutative property, right? We could also write this like that. A times B is B times A. And so what does this mean? This means 2 4's added together. And you'll notice that in both cases we get 8. Cool. So that's what multiplication means. And in the same kind of vein, exponents are what this relationship to addition is. Multiplication is essentially addition. Exponents are essentially multiplication. So what does x to the third mean? It just means this number, right, multiplied by itself this many times. So x times x times x times x. Whereas the multiplicative thing, 4x, means this number added to itself 4 times. And so in a similar vein, 2 to the third, it means this number multiplied by itself 3 times. So it's 2 times 2 times 2. Okay, cool. So now let's get to the rules of exponents. The first one's called the product rule of exponents. And it goes a little something like this. X to the a times x to the b is equal to x to the a plus b. And so what does this mean? Well, in English it basically means if you have the same base, right, the same number on bottom, but different numbers on top, it's equal to that same number on bottom with the tops added together. So the product of the exponents is the sum of their powers, essentially. And so for an example, x to the fourth times x to the third, this is x to the seventh, but let's prove it. Well, so why does this work? Well, because remember what this means. This is x to the fourth times x to the third. This is essentially x times itself 4 times. 1, 2, 3, 4, right? And so there's the little multiplication symbol there. And then what does x to the third mean? Well, it means x times itself 3 times. And so now if we drop the parentheses because everything is multiplication, right, and we have the commutative property of multiplication, which means a times b is b times a, we can essentially drop these parentheses. And you see that we have 1, 2, 3, 4, 5, 6, 7 x's. And what does that mean in terms of exponents? Well, x to the 7th, which is exactly what we got there. So hopefully that makes sense. Next we have the quotient rule of exponents, which quotient means fraction, so division. And this one is kind of like the cousin of the one above it. It's x to the a over x to the b is equal to x to the a minus b. And so if I had x to the fourth over x to the third, this rule tells me that it's x, the answer is x to the 4 minus 3, which gives me x to the first. And so to kind of go through it like we did with the other one, x to the fourth over x to the third, well, what does this mean? It's the top one is x times itself 4 times, so it's x times x times x times x. What does the bottom one say? X times itself 3 times, x times x times x. And then so we can kind of make 3 separate fractions or just cancel, whichever you're comfortable with, right? We can cancel this x with this one with this one, that one with that one, and we're just left with x over 1, which is just the same as x, which is x to the first, right? And so you can see that these answers match. And so this is kind of like a shorthand way of doing this. Cool. And then we have the power rule of exponents. Okay, and what does that look like? Well, that is a to the, let's do this with x. X to the m to the nth power is x to the m times n. And so to give an example, this would be like x to the fourth to the third power is actually x times x to the power of 4 times 3. Just multiply the powers and you get 12. And so let's quickly do the proof of this one. Well, okay, we have x to the fourth, and then we're cubing that, right? We're raising this to the exponent. Well, what does that 3 mean? It just means take whatever's on the inside and multiply it by itself 3 times. So really what we have is x to the fourth times x to the fourth, right? Times x to the fourth. And we can use the property that we learned above, the product rule of exponents, right? Because this really means x times x times x times x. Okay, that's the same thing, x times x times x times x. Okay, this one is the same thing, x times x times x times x. So we can drop the parentheses. How many x's do we have? We have 4, 8, 12, so x to the 12. But notice once you get to this point, you can also use the product rule of exponents, which is 4. This is equal to x to the 4 plus 4 times x to the fourth, which will give you x to the eighth, right, with these two combined first, and then times another x to the fourth, which is this guy right here. And we can just do that property again, 8 plus 4, and you notice that we get 12 again, right? So no matter what rules we're using, we have to be able to get the answer the same no matter which rule we apply, right? So in this case here, when we used this one, we didn't really apply any of the rules. We just kind of did it by hand, and we got x to the 12. But here, we jumped and we used the product rule that we just learned above of exponents, and we get to the same answer. And that should happen no matter what you do. Okay, cool. And then the last part of this is kind of like an explanation for something that you guys may have seen before, but maybe you don't understand. Why is x to the 0 equal to 1? Right? Why is any number to the 0th power equal to 1? Well, for one reason, it's the multiplicative identity, which basically means that 1 times any number, right? 1 times 4 is just that number by itself. So 1 times x is just x. So multiplicatively, 1 doesn't do anything. But, okay, well, what would be another possible thing for this to be? Well, it might be 0, right? That's maybe what your intuition is telling you. But let's use the product rules that one of the rules that we just learned. So if we had x squared, right? Well, this is the same as 1 times x squared, right? Okay. And so if this is true, this is the same as x to the 0, right? Because we're saying x to the 0 is 1 times x squared. And now, what does the product rule tell us to do when we're multiplying two exponents with the same base? Well, it tells us to add them, right? And so notice we get back to x squared without the 1. Okay, so that one works if x to the 0th power is 1. This still functions. The x to the a times x to the b, this is still x to the a plus b. This rule still works, and we want all our rules to work. We can't have them not work sometimes. And so what happens if x to the 0 is 0? Well, notice that x squared, right? This is the same as x squared plus 0, right? Because 2 plus 0 is 2. Okay, and then so from here, we can break this up using this rule in reverse, which would tell us x to the second times x to the 0th power. But if x to the 0 is 0, right, this tells us that it's x squared times 0, which is 0. And notice how these two things don't agree. So if this were the case, if x to the 0 was 0, that means no matter what exponent you wrote, this would just be 0, right? It would always be 0. So then there wouldn't be a point of even having exponents, right? It wouldn't add anything for us. It would just be always 0, which is pretty useless. So in case you wanted to know why x to the 0th power is 1 and not 0, why is it only 1? It's because it's the only number that holds up this property, right? X squared is equal to x squared. All right, cool. See you in the next video.